there any questions that you may have had from our last session? Okay, don't all answer at once. Okay, if you do have questions, again, if you have a question, just unmute yourself and ask the question at any time. It's not a problem. This is a very informal atmosphere. I like to keep it that way. This way we can all talk to each other and get as much done as we can. Okay, so last week, as I said, what I'm trying to do now is to get you as familiar as possible, and we have all this time now to do it as well, to get you as familiar as possible with all the functions of SolidCAM, not just a quick demo. This way also, so if you want to show specific things or want to investigate more into the program, you'll know exactly more or less of what you're doing. And this is a good opportunity to do that as well. Okay, so having said that, I'm going to continue with the actual the profile operation, because there are certain things over there I'd like to go into a little further, and then I'm going to touch on the pocket operation. Okay, now in order to show the profile operation, what I didn't show last time is as follows. When I showed you last time machining on the outside, I used the iMachining. I used the option of iMachining, and there was an option here called machining the outside feature. But let's say we don't have that, okay? And we're working with a regular profile operation. How can we do the outside with a profile operation? Okay, so, and this is what we used to do also before we had that option. So if I were to go to my profile operation, okay, we get our dialog here, as we always get, and we have what we call general, and we have silhouette, the way we create our geometry. Okay. I'm going to start with general, because this is probably the best way to do it when using this particular option. There's more flexibility with this as well. If I were to click on new, let me just do that again. I may have done that a little bit too quickly. To create the new geometry, I'm going to click on new. Now, you'll note on the left-hand side, we'll be creating basically what we call a chain geometry. Now, in this particular case, I cannot use the option of Smart Face because I want to go on the outside, and there's no possibility for me to choose the outside face over here. There's nothing there for me to choose. So in that particular case, I'm going to use what we call the actual chain, creating an actual chain. Okay, now, when I create a chain, it's basically picking an edge. Okay, now before I pick it, I'm going to uncheck what I have here. What I have here checked was tangent propagation and constant Z, and I'll explain that in a moment. So let's start creating a chain geometry. By creating a chain geometry, I'll start by clicking close towards this edge. I want to go around the part. So I'm going to start by closing this edge, and you'll note it shows where it's starting from. You can see that by the arrow. And the reason why the arrow is starting from here, I was closer to this edge rather than closer to this edge. Had I been closer to this edge, it would have started from here. Okay. At this point, I can also switch directions. So if I were to want to switch directions, we have here something called reverse. Clicking on reverse, as you see, now switch the direction. Clicking on it again will switch it back. Okay, actually I do want to go in this direction. Now it stopped over here. It didn't go to my next line. And what it's showing me is it's suggesting which way I should continue. But it's also highlighting this line over here. I don't know if you can see it that well, but it's also highlighting this line over here. Okay? So I can either physically pick this line or I can physically pick this line. Now, the suggested arrows gives me another option. Okay? What the suggested arrow actually does, okay, let me just zoom in a little over here. Let's go back to my left-hand side over here, and you'll note this over here, add selected element, okay? So instead of me clicking on the lines, I can if I want to. I can click on add selected element. You'll note if I click on it, it'll choose and then go to the next element. And it's showing me again this. Now, if for some reason I want to not go this way, but go up this way instead, I can either click on that line, or if you'll note just under where I have add selected elements, I also have an option here called change direction. If I click on change direction, look what happens now. You'll see it'll change its direction where it's suggesting it to me, for me to go. I can click on it again, it'll go back down here. Okay, but I still want to go in this direction, so I'm just going to continue clicking on this. You see it's going over there, and I can click on that again. Now, when it gets to the very end, what I mean by the very end, that it exactly reached where I started out from, it's asking me if I want to accept that. Now, I can always say, don't ask me again, and just accept it every single time I do that. And now you'll see I have my first chain over here. Now, I'm going to delete this for now. And I'm going to do what I did again. Okay. This time, I'm going to add something called constant Z. What that does for me is as follows. I'm going to choose a line over here. And if it sees that my continuing line that I have over here is on the exact same Z level, it'll continue without me having to choose it. So let's see what happens this time when I choose this line. This time when I chose it, it went completely around to the end. In other words, I only had to pick the first line, and since my constant Z was always being, has been chosen, it'll always look for that Z. Okay. Another thing to note over here also as well, in this particular case, if I right-click, I have here my chain. If I right-click on it, I can always replace it, and I can always edit it. And I can also always reverse the direction if I want to reverse the direction of the entire chain. Now, why is the direction important for me, especially for profile operation? Because this defines the direction that my tool will be working. In other words, since I'll be working on the outside of the part, and I want my tool to be doing a climb milling, so it'll work on the outside over here with the climb milling. Okay, in that direction. Okay. If I would be working not climb milling but conventional, I can always reverse the direction as well. But I don't want to reverse it for now. Just leave it the way it is. Okay, so that's the basic of the choosing chains. Now, since I'm here already, let's look at more options that we have for creating chain geometries. I'm going to delete this for a moment. Or in fact, what I'm going to do even easier, I'm going to go out and go back in to create a new operation, a new geometry. Down at the bottom, we have here curve and closed corners. What does that do? Curve and closed corners, in this particular case, you may not be able to see it. Ah, yes. If I were to pick this line here, It's stopping over here. It picked that curve. If I were to choose this line here, you'll note that they're not attached to each other. This will automatically take the shortest route between these two curves and connect them as well. If I was not using curves plus close corners and only using curves, okay, let me disregard what I did. If I were to be using curves, not the curves and close corners, and I choose this, and then I choose this, it'll start, sorry, my mistake. I'll delete that. What actually happened, since I have the constant z, it took that entire chain over there. So let me just delete what I did over there. I'm going to get rid of these options here for a moment. And I'm going to use just chain. If I were to click on this chain, this edge over here, and then click on this edge over here, it will not pick that edge. Why is it not picking it? Because it's showing me what are the possibilities for me to pick. Okay, so I only pick chains that are attached to each other. However, if I change to close corner and close corners, what will happen is if I choose this now, it'll continue on as shown before. Okay. I'm not going to go into loops because loops really isn't that useful. I'm just going to leave it alone for now. But I'm going to go now into something called point to point. If I have to choose point to point, it's exactly what it sounds like is exactly what it does. I can pick any point and it disregards anything that I have as far as the target goes. And it's just going to go exactly according to where my points are. I can go here. Of course, this way, if I machine this way, I will be ruining my part. But sometimes this is useful if I want to go to a specific point that I don't have. I can actually put a sketch on and go to a specific point on the sketch as well. Okay. Now there's another option here. And let me actually just get rid of that. Something called arc by points. Why do we need arc by points? Okay, let's just say I'm going to start first with this line over here. Okay, now, of course, normally I can pick this edge over here and this edge over here, and it'll choose that as well. But sometimes the parts that you are working on are imported parts. Now, parts that are imported, specifically parts like IGES, okay, you may see this as one element, as one arc over here, but the IGES will see this as many small points. And if I try to pick that element, it won't choose it. It'll choose some point I picked over there, and that won't work. So in order for me to get an arc over here, I have an option called arc by points. We all know the mathematical rule that if I pick 3 points, I will automatically get only one arc. There's only one arc I can get from 3 points. Now, in this particular case, you'll note that I already have my first point. My first point is actually over here. You'll note I'll get a message at the bottom that says, pick next point. So if I pick any point over here, and now it's asking me to pick my third arc point, I'll pick this point over here at the end. You'll note that it forms an arc over there. This is very helpful when you have a part that may look like an arc, but it's really maybe a spline or a whole bunch of different points as it is. Okay, so these are tools that are always helpful when you get into a jam. Okay. I'm just going to delete everything I just did over here. And I want to go back now to what I originally was doing. I'm going to choose my constant z. I'll just choose this edge over here. And it's going around and choosing my geometry. And I'll accept that. Okay? and it gave me my geometry using general. Okay, now let's continue on. And this part I'm going to go a little faster about choosing tools because we talked about this last time. I'm going to select the tool and let's see what I have here. Okay, I already have several tools over here. I'm going to use a 12 millimeter end mill, 3 flutes, cutting length 24. Okay. Don't forget, you have your data, your feed control, your spin control. Fill in whichever way you feel necessary. And my levels, you'll note my upper level is by top of target. And my bottom level, right now is at user fine. I can also automatically say, let's go to the bottom of the target. In this particular case, it's also 25. But just to show you that it works, I'm going to put a value of 24 in here. You'll see if I put a value of 24, it changes to user defined. If I put it back to bottom of target, it'll go to 25. Now, you may want to go past this a bit. So I prefer, instead of writing 25.5, I'll write over here minus 0.5. Okay? And you see that it's going in the down direction, in the minus direction, another 0.5 millimeters. Now, why didn't I put it in my profile depth, just 25.5? Because if I were to write in here a value, then it'll go back to user defined. And I also will lose my associativity to the part. So if there's a change in the depth of the whole depth of the part later on, it will not pick it up because I lost my associativity to it. But by using this bottom of target, or by just clicking in here and actually clicking on the bottom face, where you see now, even though it's user defined, but it's attached itself to that face, it'll stay associative. Okay. Now let's go to our technology. Our technology, basically, how do we actually want to work? Now, you'll note there's certain things I hear by default. For instance, left. I'm working on the left side of my geometry, which I said I want to do. Okay, climb milling. Okay, depth cut type. We have one way, or we have zigzag. I want to work one way to keep it at, keep it at climb milling. This particular case, rest material chamfer, I do not need to touch that for now. I want to do a rough cut. So I'll click on rough. And how much do I want to stay away from my wall? I'm going to put it at 0.3 millimeters. Now, if my tool, one more thing. Also my step down, how much am I stepping down each time? I'm stepping down 6 millimeters for each step. So in this particular case, since let me go back to my levels for a moment. Since I'm going down a total of 25.5 millimeters, so if I take this step down, so basically it'll be doing it a total of, if my math is correct, I will be doing it a total of 4, a little more, it's a little more than 4, so it's 5, actually 5 steps.
It would be 5 passes.
5 steps, exactly. 5 steps.
Yeah.
But what happens? Your 5 steps, you'll have 6, 12, 18, 24, and then your last step will be 1.5 millimeters. Okay? What we can do to help this out is do something called equal step down. Where equal step down, it'll say, okay, my maximum step down will be 6 millimeters. So I'll have the same 5 steps, but it'll now be done equally to the 25, to the 20. So my steps will actually be less than 6 millimeters. Okay. If I want to do finish, I can do finish as well. But I don't want to do finish with this end mill. Let's say it's a roughing end mill only. I don't want to use the finish. So I'm just going to uncheck finish. Okay. Now, compensation. Did I skip compensation? Yes, I did. I can say compensation on rough passes. I forgot to check that. Do I want my compensation on rough passes? I know people that actually do like using compensation on rough passes, even though they're doing only a rough cut. They like that extra control just to make sure maybe they ground the tool. It's a ground tool. Maybe their spindle throws a little for whatever reason. So they'll like to use compensation. Okay. Next. So basically all I really did here at this point was not really much. I did wall offset and I did my roughing and my downstep. And I had compensation on rough passes. My links, what do my links do? How do I want to approach my tool pass? My tool pass is starting over here. How do I want to approach it? My lead in and my lead out. Okay? So I may want to say, you know what? I like to lead in with an arc. This way I get a smooth touch onto the part. And by default, it'll take 60% of the radius of the tool. That's the default. I can put in any percentage I want, or I can say, let's just do it at a specific value. Okay? I'm just going to leave it at 60%. Okay? Now, I can also say from the center, as you see in the diagram over here, it's going from the center, then going to do its move to the edge over here, and then go over here like that. I can also say from a specific distance. I can say, okay, I'm doing an arc of 90 degrees. I want to have it 0.2 millimeters away, and then it'll work its compensation at that 0.2 millimeters. Okay? I can also say my lead out, I also have separate controls for that. We'll go into these later on. I can also say I want to have it the same as my lead in. If I do same as lead in, you'll note this is grayed out, and you'll see that my lead out is the same as my lead in. Okay, let's just do save and calculate. Now you can see my top view over here. I have my top view over here. You can see my lead in. It goes around, and then you can see my lead out. And you'll also note that it does this for each level. Okay? Let me run my actual simulation for this. Okay? And let's see what happens one step at a time. My tool will go down. It'll go around. Go around here as well. And when it finishes, now it's going to arc out. Now we jumped up. Okay, you may ask, all right, why is it jumping up? As default, we have it go to its clearance level before it goes to its next step. The reason for that is, in this particular case, it's heading, it's at the exact same spot where it started off from. But let's say my geometry was from here just to here. If I wouldn't go up to my clearance level and stay down here, it'll actually cut across to the part and ruin the part. Therefore, it goes up by clearance. However, let me go back into my operation for a moment. If I double click on the operation, it goes back to the edit mode, and I'll go back to my links. Okay? You'll note that in my links, I have the following. Passes through, as it's going from one level to the next on the same chain, it's going to my clearance level. I can say, let's just go safety distance to my upper level, or the level of the current path. Let's be brave for a moment, and let's do this. Keep it on the current path. Let's see what happens now. Run my simulation. Let's run it slowly. I'll stop it just before it gets to that point. Okay, now I'm going to do one step at a time. It's going to finish out. And then it goes directly to its next pass. And then it goes down. Okay? So you actually have complete control as far as your clearance level. At default, to always be on the safe side, we put it at clearance level. Now remember one thing. If this is the way you always want to work, remember the last couple of times, you can create a template and save it as a template. Okay? So if you always want to work in a specific way, you can create a template. Such as this, I'll create a template and I'll call it contour 12 millimeters. I know what tool I'm working with. And I'll say stay down. Stay down on link. Okay? So this way I know exactly what I'm using. If I go click on OK, I have that template. Okay? How do I use that template? Again, within the operation, I can say load template, and I can say just use that. So in any operation that I create after this one, I can use that template to use the exact same parameters, and I can edit anything I want. In other words, I can create a new geometry and whatever I need. So just remember about the templates. I'll always remind everybody about that because it's a very powerful tool. Okay, I did my first operation. I need to do a rough operation. Do I need to create a new operation? Yes, I do. However, I want the new operation to already have many of my values that I already have over here. So how do I do that? If we look at the bottom over here, we have an option here called Save and Copy. If I click on Save and Copy, it creates a new operation based on my old operation, and now it's opened up to my operation that I'm editing. In other words, the new operation. And all I need to do now is make any changes I want. So for example, if I wanted to use a different tool, I can come back and say, okay, I'm going to make a copy of this tool instead of just creating. We have what they call copy tool. So it made a new tool based on the old tool, but now this is a finished tool. All the same parameters. I can change them if I want. On purpose, I'm not changing it. My levels will be the same. My technology, I am not doing a rough cut. I'm just doing a finish cut. And you'll note my maximum step down is set at 0. If I leave it at 0, it'll take the entire step at one shot. No, the entire depth at one shot. Okay? Let's just leave it the way it is. I'll put, of course, compensation on my finish passes. My link, I'm going to save it. You know, I'm going to leave it the exact same way. I'm just going to do save and calculate. I'm going to run my simulation. Actually, let me just get rid of that check mark over there. You can see it's done one pass over here, according to my preview of my tool pass. If I were to run my simulation, and this time I'm going to use Solid Verify. Okay, again, over here, my simulation, we were in a host CAD before. Now I'm using what they call Solid Verify. Okay, again, I'm going to run it one step at a time. Let's see what happens when I run it. It goes down, and it goes into the part. And note, it says there's a clash in here. Why is there a clash? Anyone? Okay, don't all answer at once. Go ahead.
Because the reference is not big like the material.
Okay, because the cutting length of the tool is more than the material. My cutting length was 24 millimeters, but I'm going down 25.5 millimeters. And I also still have material that I didn't take off my face mill on top. So I can do one of two things. I'll stop. I can go into my operation, and if I insist on using this tool, I'm going to say that my step down should be, say, 13 millimeters. Okay? This time, if I do that, I still may have a crash, and I think I know why also. Sorry, let's do solid verify. The solid verify will notify me immediately if there's a crash. No, actually, it'll work fine. Okay?
Yes, but we need to add 2 passes. He did it in 1 pass.
It did it in 2 passes. Look, again, first pass.
Yeah, but you didn't mention in the note that. Yeah, but sorry, you wrote just 1 pass. Can you go back to the.
No. Okay. I did maximum step down. Now you're asking, what is this?
Exactly. This is what I'm asking, because I thought that I needed to do 2 now.
Very good. Okay. The reason what this does is actually like this. And you probably all notice also as well that let's say you have a tool that's pretty long, okay? And the wall is also a pretty long wall. If I were to take it all down in 1 pass, most likely your wall will not be exactly straight, okay? Because there may be some deflection because of the tool, okay? If I'm wrong, correct me, but that's usually what will happen, okay? So many times...
It's right.
Okay, so what many people would like to do in that particular case is, okay, I'm going to do 1 pass around the thing, and then I want to do another pass with the exact same pass again to take out that deflection. So let's see what happens if I do this number of passes, let's say 2. Okay, save and calculate. And I'll run my simulation again using solid verify. I'll slow this down and let it run. It's doing my first pass. It's doing a second pass on the exact same pass it did before. And now it's going down to my next pass, and it's going to do the exact same thing again.
Okay.
Okay.
It's good to know it because, sometimes you need to do a finishing operation and you want to run it again on 0 AE. So this is the option to use, right?
Right. Exactly. Okay. Now, one more thing I didn't notice. What normally happens? This is actually a simple part. We have the edge over here. What if there's a round part? Okay, a round part. And with the round part, what happens is I have my lead in and lead out. Everything is fine. But it goes to the exact edge. Let's say it started over here. It goes over here and then goes out. What normally happens at that point? You normally leave some kind of a mark over there. Okay? What many people like to do is they'll say, okay, I did a round part. When I get to this part over here, I want to go just a little further just to make sure I cut everything off over there. Okay? We have what we call extension overlap, where it'll actually extend my geometry a bit. I'm going to put it now at a large value so that you can see exactly what happens. Let's say 5 millimeters. Okay? Save and calculate. Okay? Let's take a look just at my tool pass. Okay, from the top view. You'll see, here's my lead in. It's going around the part. Now, when it got back to this spot, it went another 5 millimeters along the geometry and then went out. Okay, so it extended the geometry to make sure it's covering that area. Now, this is a particular edge, okay? But let's say this was a round part. There is no edge over here. So it normally would leave a mark if I would go exactly to this point. This allows you to extend that area over there. Okay, any questions at this point? Okay, I'm just going to go back into this operation here in itself. Okay, at a different point, I'll explain the rest of these areas, except for one thing. There's something here called clear offset. And I'm going to go actually back to my first operation and explain what that is. Okay? We have here what they call clear offset. Let's say my stock that I have over here, okay? The stock, for example, and it's the only stock I have. I don't have any other stock. It has an extension of, say, 10 millimeters at the edge. Okay, it's 10 millimeters oversize. That's one example. So what would happen if I worked the way it is? I'm going to have my entire tool going directly into here. And that's not necessarily the best thing to do for the tool itself. I can do what they call a clear offset. Clear offset, I can say, you know what? Let's start from, say, 8 millimeters outside. And then I want you to step over every 4 millimeters. Okay, you know what I'm going to start? Yeah, okay, I'm going to say every 10 millimeters. Start at 10 millimeters outside and then step over every 4 millimeters. Let's see what the result of this is going to be. The result is as follows. It starts from further out and then steps over, it does a round, and then steps over every 4 millimeters until it gets to here. Okay, so this is from 10 to 6 to 2, and then up until the offset of the part, to 0.3 millimeters before the actual edge itself. Okay. So that's what the clear offset was. Okay. Any questions? Okay. We will continue on down. I'd like to move away now from the profile operation. Okay. And now I'd like to go into my pocket operation. Now, we've touched upon pocket operation several times, but I'd like to go a little more into depth into it. So I'll hit on pocket. By the way, how is my internet connection? Is it so far okay?
Yes, it's good. You can hear you very well.
Very good.
Okay,
Very good.
because yesterday I was having issues like crazy. Okay, and I was really worried about this. Okay, okay, so let's continue now. Pocket operation. Again, you'll note the format in my operations are very similar from one to the next. Now, in pocket operation, we have several more issues over here, several more options over here. But let's leave these operations alone, these options over here alone. Let's go just basically to the basics. Okay, now I would like to do this particular pocket over here. Okay, so again, creating a new geometry. One more thing. I'm sorry. I always forget to tell everybody this. You notice how I'm always moving my window away to see my part? If I were to go to my window over here and just double click on the top part of it, okay, it'll show me, it'll fold up temporarily. Another double click, it'll come back down. So sometimes you're looking where to put the window, it's bothering you. Just double click on top of it and it'll disappear. Okay. So now I'm going to create a new geometry. And I'm going to use the option that I had before of Smart Face. Okay, remember if I clicked on Smart Face, what does that do for me? One, it picks out that exact face. It also automatically recognizes the open edges. It does not pick the edge of the hole because I want to machine over that. But it does also automatically pick out the stubs that I have inside over here at all. Now, if I didn't have Smart Face, okay, or for some reason I couldn't use it, let's actually mark these all off over here. Delete them. Okay? Or I can just go out of here and just go back in. If for some reason I could not use Smart Face, I'm just unclicking that. I can actually do it also by having constant Z, clicking on one edge over here, and it will pick that entire area over there. However, the minus of this is that it does not recognize the open edges automatically. Okay, so my question is, or your question would then be, okay, so how would I mark the open edges? Okay. By the way, if this over here is bothering you, I can say don't show. It's showing the chain on the work plane. If you see this over here, on the left-hand side over here, I can get rid of that so I don't have to see it. Okay. So how do I mark open edges? If I were to right-click on my chain, okay, we have an option here called Mark Chain as Open. It's going to take my entire chain and mark that as open, but I don't want that. I want to mark open edges. Okay? You'll note mark as open. All I have to do is click on the edges. This one here, this one here, this one here, this one here, this one over there, this one over there, and this one over there. Now, obviously, you note that picking a Smart Face is a lot easier. Okay, just accept that. But I'm not finished. Now I have to go and continue picking my studs. So I'm going to pick it over there as well. That's the second one. The third one. And the fourth one. Okay? So now you've seen the difference between Smart Face and picking individually. Smart Face is a lot easier to work with. Why do I have to mark this as open edges? Because if it is a pocket and this is a closed edge, it'll only go up until that edge. Okay, let me take the top view. My tool, when it comes to this edge over here, will go only up until here. And it will not machine that corner. But with open edges, I have to go outside of it. So that's why I need to mark the open edges. Okay, I'll accept that. Sorry. Again, I'll choose my tool. And on purpose, I'm going to use, again, that larger tool that I had before, that 12 millimeter end mill. The exact same tool. If for this operation I want to change my feed and speeds, I can. Changing it over here will not affect the previous operation. It will just affect this particular operation. Okay, so I chose my tool, my levels. You'll note that it's automatically at 10 millimeters because that's where I picked my face. However, this is not necessarily associative, so I'll pick it again just by clicking on it. Okay. Step down, I'm going to leave it now for 10 millimeters. Okay. Technology. How do I want to work on my pocket? Okay. We have several different technology types called contour, as you saw in that picture that you see over there. We have also called hatch. You'll see we have a separate technology for hatch where it goes back and forth. We also have hatch plus finish. I find the most useful is contour. Okay. Contour can work either from the inside going out or from the outside going in. Now, since we are working with an open pocket, okay, here, you see it's an open pocket. We mark the edges as open. This option, this tab over here is available to us, and it's called open pocket. Because when I work with open pocket, I like to do certain things. I like to make sure I'm approaching from the outside where I can. Of course, if I don't want to, I can uncheck that. And I like to use what they call a profile strategy and work one way. In my links, you'll note that I have here something called ramping. If I had a closed pocket, okay, how would I want to actually go into that pocket? And by default, we helical in. We have several different ways, also vertical, where it goes from the top down, or going in at an angle, or a linear, which is actually the same as the vertical, as angle. But I'm just going to leave right now as helical. In fact, however, in this particular operation, this will not affect us at all, for the simple reason that this particular pocket that I have over here is all open. I have all open edges over here. Okay, so for that, I still have my lead in and lead out. Okay, let's do my lead in at tangent this time. Okay, and I'm going to do my lead out the same way. Okay, sorry, let me go back to my technology. I skipped over this by accident. In my technology, when I'm working, how much of an overlap do I want between the tools? Okay, we have it set at 50%. I know people who prefer working at 60%, not to go exactly 90 degrees into the tool. Okay, how much of an offset do I want on the wall? Let's say 0.3 millimeters. And I can also do a separate offset for the floor. Let's say 0.15 millimeters. Okay, I'm not going to do a finish. I'm just going to do a rough cut. And I'm going to leave everything the way it is. Save and calculate. Okay. I want you to take a look at the toolpath itself. This is what they call a profile type of toolpath as it's going around. And you'll also note certain areas where it could not machine. If I run my simulation and I'll do solid verify, you note it's going from the outside where it can. And in these areas over here, this particular area over here, it could not work its way in. Okay? So, how do I deal with that? Let's go save and copy. Remember that. What happened here? Oh, I know why that happened. I'm going to take this. That's irrelevant. Okay. And I'm just going to choose a different tool. And the tool I'm going to choose this time, let's say I don't have it here. So I'm going to choose a tool. I'm going to create a new tool that's 6 millimeters. Okay? Of course, everyone puts in their length of the tool, whichever they want. Let's say this was, let's say, 12 or 13 or whatever. Cutting number of flutes, the tool data. I'm not going to go into that, but you know what to fill in. Levels, I'm going to leave that the same. Maybe my step down, I may change it a little bit to say just go down every 3 millimeters. And in my technology, we have here something called rest material. Rest material chamfer. I'm going to choose what they call rest material. In rest material, I'm just going to tell it what the diameter of my previous tool was. If I know it, I'll write it in. If I don't, I can always go and looking over here. I'm just going to write in here 12 millimeters. Okay? I'm going to leave this the way it is. I don't need to deal with that right now. Okay. You'll note, however, one thing. I will deal with one thing. There's something here called extension overlap, and there's something here called feed. Actually, for this particular operation, I don't need it yet. Forget that I said what I just said. Skip over that. All I did need here was the previous tool diameter, 12 millimeters. My link, I'm going to have that as arc, and the same thing for my lead out. Let's see what happens in this particular operation. Okay? You'll see that it works only here. Let's run the simulation. And I run it again using Solid Verify. And I'll do this one step at a time. You see that it's going into that area over there. Let's do it actually pretty slowly. Cleaning it at one side. And then cleaning the other side as well. Okay? Now, there is another way to do this also for that area. Okay? I'm going to go back to my technology, where it says here technology on top over here. And when it says rest material chamfer, I'm not going to use it. I'm going to say none. Okay. Now, if you remember at the very beginning when I spoke about pocket in the geometry area, I mentioned that there was a lot of things here as well. One of the things that we have here is called cut only the rest material. Okay? Cut only the rest material will only work in areas where there's material to be removed. Okay? Let me show it on the model. You can see what was cut away, and you can also see what was left over. Okay? Let me go to my levels, my technology. I want to put in my offset here at 0.3 millimeters, if I remember correctly. Got to put that in before. Now I'm going to do save and calculate. And I hope this works. Okay. Now, the reason why it worked on these sides over here, because it's sometimes with this particular case, with the geometry, cut only rich material, since I put my offset at exactly 0.3, sometimes it's what they call a discrepancy. It'll still see that material because it's exactly 0.3. So it's when it comes to checking the facets of the stock, it's not always exact. So since it does see something here, it'll work there also. A trick to get away with that is if I go back to my technology, go to my wall offset, and change it to say, for this particular ation, say 0.35. Sometimes this works.
You did 2 points.
Sorry? You're right.
Yeah.
I'm sorry.
2.
You see,
One.
you're right. And you notice what happened when I did the save and calculate? It told me I did something wrong.
Yeah.
Okay?
Exactly.
Exactly. And it also highlighted this area. Okay, so just go back here, 0.35. Sorry? Not 0.35, 0.35. Okay, there's still some discrepancy over here. Let's try 0.4. Still some discrepancy. So this is not always the perfect way to do it. Okay? Sometimes you have to play around. This is why we still have the old option in technology of rest material. By using that again, over there you'll never fail. It'll only work in the area where it's supposed to. And I can go back in here, by the way, with my technology offset. I can put it back I thought I was able. I have to figure something out over there. Did I see there's some little discrepancy over there? This should be actually back at 0.15. I'll check why they didn't do that at a different point. Okay. Basically, yes, go ahead.
This is because the diameter of tool is big.
No, because why? Why didn't the wall offset is still at 0? Oh, and why
No,
why it's only working here?
Yeah.
Because the previous tool was too big to go in here.
Understand. Okay, thank you.
Okay, and therefore, since I'm now using what they call rest, so it's only going to work where, hold on a second, if I go back to rest over here, which is rest, only where the 12 millimeter tool could not go in. Okay, all the other places, it'll work, such as over here, in this particular case.
Thank you.
Okay, no problem. Now, I'm going to do one more thing over here. I'm going to do what they call, again, save and copy. And with the same tool, for whatever reason I decided, I want to do a finish cut. Okay? I want to do a finish. So I'm going to go back to my technology. I'm going to get rid of my rest. Don't want to use a rest. Okay? And we have here options to do a wall and floor finish. But I also have an option. But if I do this right now, it's going to work on the empty area and go down. But I don't want to do that. I'm going to say like this. I want to do a wall finish only. Sorry. I want to do a wall and floor finish only with this tool. So it'll work on the floor and then work on the wall. Okay. Why do I still have my wall offset still open? Very simple reason. When I'm working,
You need to decide if it's a finish.
I need to leave some offset when it's doing the floor finish. It's going to first do the floor finish up until whatever offset I have over here. And then it'll do the floor. So, wall offset, 0.3, it's going to work on the floor. And note, I just want to note one more thing. Go back to my levels. When it gets to the wall, it's going to do the floor and go straight to the floor. And my wall then, it's going to go down every 3 millimeters. Okay? I can change this if I want. I just want to show how this actually looks at the end. Okay? Let me run the simulation. Again, I'll use the Solid Verify. You'll know it's first doing the floor. And now it's doing the wall. And you see it's going down 3 times on the wall. Okay. I'm going to finish now, but what I'd like you guys to do is you have this part. I'm going to have this recording. I'd like you to machine the part, and I want you to continue by machining also these areas over here, these pockets over here, these areas, and this. And next week, when we get back, and including, by the way, don't forget maybe a profile operation on these steps over here as well. When I come back next week, I want to work on also the chamfer recognition for this, to be able to put broken edges on this. And we're going to start also with drilling. Okay? There's a lot that we looked at drilling. So you have what to do in the spare time. Next week, we will not be having a class. But in 2 weeks, we will be having a class. If for some reason there will be a change, I will let you know. I will inform you. Okay? Any questions? Okay, I guess we're done.
Thank you very much.
You're very welcome. Happy holidays to everybody, whoever's celebrating Passover or Easter, and if you're not celebrating any of that, well, celebrate something. Okay, take care, everyone, and stay safe.
Thank you.
You're
Thank
welcome.
you. Thank you, sir.
Thank you very
Take
much.
care. Bye.
Thank you. Bye.
Bye.
Bye-bye.
Bye.
Thank you very much.